All right, 9.4, inscribed angles and shapes. Buckingham students will find the measure of inscribed angles and find the measure of angles of inscribed polygons. So inscribed, that means touching and inside another shape. And then there's another word you might see called circumscribed. That means touching, or intersecting is probably a better term here, but touching and outside another shape. So basically we have this really unique relationship with inscribed angles, and it'd be fun to play with it a lot more if we had some time, but it's really simple, and it's that if an angle is inscribed, and what do I mean by that? I just mean that it's touching the edge of a circle. So inscribed in a circle, it's touching the edge of a circle. So if it's anywhere inside this circle, then the measure of the angle equals, this angle would have to equal exactly one half the measure of its intercepted arc. What do I mean by intercepted arc? Well, take a look here at this angle. See how if we follow it along, it hits A, and if we follow it over here, it hits B. That makes AB the intercepted arc. And we've already learned from previous lessons, basically, that this arc measure, not arc length, arc measure, is the exact same as whatever this central angle is. So we find out that this angle here, this inscribed angle, is exactly half of this arc measure or this central angle measure. So I have some fancy formulas here that we could look at to kind of talk about it. We could say that that angle APB equals half of this measure arc AB, or we could say if you multiply this angle by 2, it will equal this arc measure. But really it's pretty simple. All it is saying that it's half. And remember, these are supposed to be little arc symbols. I don't really have great options in my program. So let's play with this idea in circle number 1. In circle 1, it gives us several arc measures. Arc measure AB is 140, BC is 100, and AD and DC are the same. Find the measure of each numbered angles. Remember, AD and DC, these are the same even though they don't look like it. Remember, we trust the information, not the drawing. So let's just start plugging some stuff in. AB is 140, so that's this guy. And BC is 100, and then says these two are the same. Well, since that accounts for all of the arcs all the way around the circle, we could actually figure out what these two are just using some simple algebra. So if I was just call it X, we could pretty simply say that 140 plus 100 plus X plus another X has to equal what? Well, all the arcs in a circle we know add up to 360 degrees, so we could just solve it from here. We get 240 plus 2X equals 360. Subtract 240 from both sides, we get 2X equals 120, therefore X is 60. Again, I know it doesn't look like it. These numbers are just kind of made up, but that's what it is. And we could check our math here. Does this add up to 360? Well, 100 plus 140 is 240, plus another 60 is 300, plus another 60 is 360. So yes, this is all correct. Now, what does it want us to do? It wants us to find the measure of each of the numbered angles. Well, let's just take a look here. Should be pretty easy to do. I'm going to kind of list them all over here. We've got angles 1 through 5. And it's just as simple as using the rule that we learned above, that the inscribed angles, the angles that are on the edge of the circle, are half the arc they intercept. So let's start at angle 1. Look where angle 1 intercepts. It goes to A, and it goes to D here. Well, that's this arc, arc AD. Well, if that arc is 60, what does this angle have to be? It has to be 30 degrees. Pretty simple, right? What about angle 2? Well, angle 2, let's follow it. Angle 2 goes to D, and it goes to C, so it intercepts this 60-degree arc as well. So angle 2 must be half of that, which is also 30. That's really all there is to this, just half of the arc. So pretty basic. Let's do one more. We got angle 3. Angle 3 goes to C, and it goes to B. Well, BC we know is 100, so angle 3 has to be, that's right, it has to be 50. It has to be half of 100. Okay, I want you to try the last two on your own. Just give it a quick little try. I think you'll be able to figure it out pretty easily. Okay, so hopefully you saw that angle 4 intercepts this arc of 140, so it has to be half of that, it has to be 70, and angle 5 intercepts this arc of 100, so it has to be half 50. In fact, angle 5 and angle 3 intersect the same arc. They intercept the same arc, so they actually have to be congruent angles. We could kind of mark that if we want in our drawing, we don't have to, but just kind of significant that since these two angles intercept the same arc, they're congruent, which is what we're going to learn about here soon. Okay, so what else does this mean? Well, this kind of gives us this theorem that the inscribed angle is half its intercepted arc. It gives way to a lot of other theorems. For example, the next one, the right inscribed angle theorem. Now, I just named it that because in our textbook it just said like theorem 10.3 or something like that. So I gave it an actual name. Right inscribed angle theorem. So what does this say? It says if an inscribed angle intercepts a semicircle, the angle is a right angle. Well, let's think about that. So let's look at angle B here. Well, angle B is intercepting arc AC, and we could call it ADC. That point should be on the actual circle. So, well, if this is the center, then arc ADC is exactly half the circle. So it's 180 degrees. Well, anytime you have an angle that intercepts an arc, right, an inscribed angle intercepts an arc, it's exactly half. Well, what's half of 180? It's 90. And so we now know that anytime we have an inscribed angle that goes straight to half a circle, it's got to be a right angle. And that's just something we're going to need to be able to see really quickly. So if it goes right through the center, if it intercepts an arc that goes, right through the center of the circle, then we know that angle has to be a 90-degree angle. So how could we apply that? Well, let's take a look at this next problem. Example number 3, triangle ABD. Probably should have changed that number, sorry. Triangle ABD, so there's that triangle ABD, and ADE are inscribed in circle F. Right, so we could see that A is on the circle, E is on the circle, and D is on the circle, and so is B. And it tells us a couple things. It says that AB, arc AB, is congruent to arc BD. So AB and BD are the same. Find the measure of each numbered angle if angle 1 equals 12x minus 8, so this is 12x minus 8, and angle 2 is 3x plus 8. Well, the first thing that I notice, guys, is that F is the center of the circle. And my angle B here goes from A, intercepts the arc that goes all the way from A to D, and that's half the circle. So right away I know that this is a right angle. Same thing's true from the other side. E here goes to A, intercepts this arc all the way to D. It's right through the center of the circle. So once again, E is a right angle. Well, kind of interesting. If a couple other things we can make note of here. If this is half the circle, we know we have 180-degree arc measures here. And if these two things are the same, then we could split 180 in two and say that these are both 90-degree arc measures. If they're 90-degree arc measures, the inscribed angles 3 and 4 that intercept those, see 3 intercepts 90 and 4 intercepts 90, would have to be exactly half. So these would both be 45 degrees. I can't write, 45 degrees. Which would make this a 45, 45, 90 triangle, which means that we could also apply all the things we know about 45, 45, 90 triangles to find side lengths or hypotenuse if we needed to. All right, well, what else do we know? Well, again, if this angle is a right angle, there's many number of ways we could find angles 1 and 2, but we could go all the way back to kind of the beginning of geometry when we first started talking about triangles and how they added to 180. I already know this angle is 90 because it intercepted half a circle. So these three angles have to add up to 180, so therefore these two angles have to add up to the other 90 of 180. So basically we could just say that angle 1 plus angle 2 has to add up to 90 degrees. Because all three of these add up to 180, I just kind of subtracted 90 from both sides. You guys have done this stuff before. So angle 1 is 12x minus 8. Angle 2 is 3x plus 8. If this equals 90, we could just solve for x and then plug it back in and find the angle. Well, negative 8 and positive 8, that cancels each other out. And 12x plus 3x, that's 15x. So 15x equals 90. Divide both sides by 15. And I believe that's 6. So we get x equals 6. Okay, again, that's not my answer. Remember, what does the question say? It says find the measure of each numbered angle. Well, we already found 3 and 4. They were pretty easy. But now we're just going to plug this back in to find 1 and 2. So angle 1 is 12 times 6 minus 8. 12 times 6 is 72. 72 minus 8 is 64. So angle 1 is 64. And angle 2 has to be its complement. So it should be 26. But let's just double check. If I plug this 6 in, that would be 3 times 6 plus 8. 3 times 6 is 18. 18 plus 8 is, yep, 26 degrees. So we found all the numbered angles. Not too bad. Pretty simple geometry once we see those right angles. All right, let's go to the next page. Okay, so this leads us to kind of talk about inscribed quadrilaterals. So what I want us to do is we're going to kind of draw this out because they're not always going to be a picture. So quadrilateral ABCD is inscribed in circle P. And when they say ABCD, that means we're going to go in that order. So really, I could kind of just pick any ones that I want. But I do know that angle B is 80 and angle C is 40. So I'm going to actually start with B. I know it seems a little counterintuitive. But just so I know, if this is an 80-degree angle, then it's going to be a little bit less than right through the center. So I'm going to put C here, and I'm going to put A here, and I'm going to put D over here. Now it doesn't matter that I draw it perfectly. I just wanted to give it somewhat of a reasonable sketch. Okay. So what do we know here? Well, we know that angle B is 80 degrees. They told us that, and they told us that angle C is 40 degrees. All right, find the measures of A and D. Okay, there's something really interesting happening here. We're going to discover it. But first, there's a lot of things that we could find out. So let's just kind of go and think about this. Remember, this angle here is half of this arc. And this angle is half of this arc. And so we can use that information to kind of fill in the blanks here. So let's do this one in red. Right? Angle B intercepts this arc. And it has to be twice as much. Right? It has to be twice as much as 80 because it's half the arc. So 80 is 160 degrees. ADC is 160 degrees. I don't know why my pen can't write there. Let's do this one in like green. So we could see that angle C here intercepts this whole thing. And it has to be 80 degrees, right? Because it's twice as big as 40. So we got this little overlap here, and we have this red is 160, this green is 80, and we have this little overlap. So how can we figure out all the rest of this shape? Well, let's just think about this. Let's ignore the part in the green. Let's just talk about the part in the red. Okay? If this is 160 degrees, and we know how far it is around a whole circle, right? It's 360 degrees. Couldn't we figure out, I'll do it in purple, couldn't we figure out what this other half is? We should, right? It's not really another half, but it should add up to 360. So if we kind of think about it, what in purple has to add up with 160 to equal 360? Well, that should be easy. It should be 200. Well, now look at this. If this is a 200-degree arc, and this angle inscribes that arc, right? This angle right here has to be exactly half of 200, so it has to be 100 degrees. Yeah, that makes sense. And in the same way, we had this green angle. I'm going to I'm going to do its opposite in brown. Say we have this green angle that's 80, and its other half or other part then, I know it's getting a little crowded here, this brown part would have to be 360 minus 80. So this part would be 280. Well, that's pretty easy to do then, because now we can see, hey, this arc, this brown arc, is intercepted by this angle here. So this angle has to be half of 280. Well, half of 280 is 140. Okay, so we found all the missing angles. Now, what I want you guys to think about, a couple things. One, all these angles should add up to 360 degrees. And we could check that. 40 plus 80 is 120, plus 140 is 260, plus another 100, 360. Because remember, we learned back a while ago that all the angles inside a quadrilateral add up to 360. So this one is no different. Now, there is something else going on here. There's another pattern. And I want you to look at it. It has to do with opposite angles. So I want you to just pause the video and spend a second and just look at the opposite angles. Take a look at these. And take a look at these. And see if you can have a conjecture about what is going to be the relationship of opposite angles of a quadrilateral that's inscribed inside a circle like this. What do you think that's going to be? And put your response in the answer choice. Okay, well, hopefully you kind of saw that 140 and 40 adds up to 180, and 80 and 100 adds up to 180. And so if your conjecture is that the opposite angles will always be supplementary, or they'll add up to 180, that's correct. In fact, that's the next theorem here. It says if a quadrilateral is inscribed in a circle, then its opposite angles are, and we could just write, supplementary. So that's a super helpful tool. And if we had known that from the beginning, we could have just easily said, oh, well, this angle is 100 because it's across from 80, and this angle is 140 because it's across from 40. Cool little rule. If we can remember that, we can apply that to lots of different problems. All right, we come to the end of the video. What I want you guys to do is I want you to try your best with the summary. You're going to have to do the drawing part on here. I might help you guys with the picture, but then do your explanation through Edpuzzle, and then also remember to give me some question that you have from the notes. If you don't have a question, make up your own math question pertaining to the notes. So let's just talk about this real quick just to help you draw it. It says draw a circle Q. Okay, so we're going to put in a circle. I know my circles aren't perfect. And its center is Q because we named it circle Q. And it says that it has quadrilateral WXYZ inscribed in it, where WY goes right through the center. So I think I'm actually going to draw W and Y first. So here's W, and here's Y, just so it goes right through the center. And it is WXYZ, so there has to be an X over here somewhere, and a Z somewhere over here. So there's WX, Y, Z. There's a quadrilateral inscribed in it. And it gives you one of the angles. XYZ is 50, so XYZ is 50 degrees. How can you find all the other angles? I'm going to let you think about that for a little bit. There's enough clues there to find all the rest, so give it your best shot. If you don't know, just give me your best shot. And I'll see you guys on the next video.